Hello everyone. Today we are going to start with a new lesson, lesson 3, mirrors and lenses. Before we start and we want to apply the law of reflection to a ray in a diagram. Before we start our lesson before we start talking about the law of reflection, I want to remind you about the how the light and the matter they are interact with each other. We said when the light interacts with matter, the matter it might absorb that light or reflect that light, or the light it might pass through that object. It depends on the material that you have. We said to see an object, the object should reflect the light, okay, to our eyes to be able to see that object. Without light, we will not be able to see an object. So the light will hit the object, then the object it will reflect the light to our eyes, so we can see that object. Without light, again, we will not be able to see any object. Also, we have mentioned that for surfaces, these surfaces they might be smooth surfaces, or they might be rough surfaces. For rough surfaces, when the light hits the rough surfaces, these surfaces will reflect the light in different direction. But when the light hits the smooth surfaces, it will reflect the light will be reflected in a uniform way, as the mirrors surfaces do. Because of this uniform way of reflection, we can see our images. If the light is not reflected in a uniform way as in rough surfaces, we will not be able to see our images. So here, to understand this, I want you to listen to this video. Then we will continue talking about the law of reflection.
Flora is getting ready for a school dance. Yesterday she went shopping to get her new dress and shoes. She also got her hair trimmed. It's almost time to leave, so she checks the mirror one more time. What does Flora see? Click the highlighted areas to learn more. When you are finished, click the next button to learn more about mirrors and lenses. It's getting late. The sun is setting. Flora has to turn on a lamp because there's not enough light coming in from outside anymore. The light allows Flora to see herself in the mirror. She wouldn't be able to see anything in the dark. Your eyes catch the light that reflects from the mirror. They send messages to your brain, which interprets what you see. Does Flora like what she sees in the mirror? Is she ready to go to the dance? I hope so. The dance starts in 15 minutes. Flora's baby brother loves looking in the mirror. It's funny when he sees himself, as he's not sure what is going on. Does he know it's his reflection, or does he think it's a different person? What do you think?
Okay, so because of reflection, we can see our images in the mirror. Okay, now I want to discuss with you when the light source or when the light rays hit a mirror or a smooth surfaces or the surfaces, how they will be reflected. We want to understand this how, and I want you to know that the law of reflection. But before first of all, you have to put in your mind always the light rays. They are traveling in straight lines. So the light waves, they are traveling in a straight lines. Now, to understand the law of reflection, look at the figure on your book, page 106. You have a mirror. In this mirror, as you see, like you see lines, red line, and something it's called incoming ray, normal, reflected ray. We want to understand this. To understand this, look at this one. Here, to understand what I'm talking about, what is the incoming ray, what is the normal, what is reflected ray. Here you have here the mirror, which is the orange line. This part, as you see, the part it has the black lines represent the side of the mirror that where you can't. It's the back of the mirror where you can't see yourself. But here the upper part represent what? Represent where you can see your image. But again, where the lines, the black lines are represented here or show here, they represent the back of the mirror, the surface where you can't see your image. Imagine there is a source of light. It's a light here, light bulb, sun, whatever. As the light is traveling in a straight line, the lines or these waves of light start to hit the surface of the mirror. So, the ray that hits the surface of the mirror, it's called incoming ray because it comes from the source of light toward the mirror. It's called what? Incoming ray. Or I'll give it another name, incident ray. Okay? This point here, as you see, is the point where the light hit the mirror. To know where the light it will be reflected or how it will be reflected, you can draw like a line. It's called normal line. The normal line is an imaginary line. This line, it makes 90 degrees with the surface of the mirror. Look. The surface of the mirror from the normal, between the normal again and the surface of the mirror, the angle it has been made, it's how much? 90 degree. Okay, so you draw the normal at the point where the incoming ray or incident ray hit the mirror. Then you can complete like making like this. This is the reflected ray at the point of the normal, and at the same point where the light hits the mirror, the light it will be reflected. Okay, this ray that reflected, it's called reflected ray. Again, it's from the point where the incoming ray hit the mirror. Then, because as you see here, there is an angle between the normal and incident ray or the incoming ray. Okay, this angle here, it's called the angle of incidence. This angle between the normal and the incoming ray, it's called the angle of incidence. But the angle now between the normal line and the reflected ray, it's called the angle of reflection. So, to show you the definition for each one of them, the incidence ray is the incoming ray, is the ray that it comes from the source of light. Reflected ray is a ray of light which is thrown back or bounced back or reflected from a surface. Normal line, the line is perpendicular to the surface. It makes 90 degrees with the surface, not with the incident ray or with the reflected ray. It's with the surface. It makes 90 degrees. The angle of incidence is the angle between ray incidence on a surface and the normal. Okay? The angle of reflection, the angle between a reflected ray and the normal drawn at the bottom of the incidence to a reflecting surface. So these are the definition for these rays that I put on this figure here, as you see. What about the angle of incidence or the angle of reflection? These two angles, as we said, the normal and the surface, it makes in both sides what? 90 degree with the surface. The angle of reflection, how much the angle of reflection, how much the angle of incidence? Here, this angle, for example, if it's 30 degree, when you use, for example, a protractor, and you found it's 30 degree. What about the angle of reflection, this one? This one, it will be equal to the angle of incidence. It equals how much? 30 degrees. So what is the law of reflection? The law of reflection, it says that the angle of incidence is equal to the angle of reflection. Okay, so this is the law of reflection. Now, what about if I give you another example? If you have here only a mirror, and in this mirror this is the mirror, the blue line, and you have incoming ray only. How to draw the reflected ray? To draw the reflected ray, first I have to draw the normal line. This is the normal line at the point where the incoming ray or incident ray. This is the normal. This is the normal. You have to use the ruler to draw the incident. The normal. This is the normal, and it should make how much? 90 degree with the surface of the mirror. So I have to make sure it makes 90 degree with the surface here of the mirror. Okay. How to draw the reflected ray? To draw the reflected ray, I have to use here from the same point where the incoming ray hits the mirror, I have to draw the reflected ray. So this is the reflected ray. Now, what about the angle? For example, as you know here, this angle here, it's how much? It's 90 degree between the normal and the incoming ray. I want to show you here the reflected first. So this is the reflected, the direction of the arrow to this way. What about this angle here? For example, I gave you the angle between the incoming ray and the normal is 50 degree. What about the angle between the reflected ray and the normal? It should be what? 50 degree also, depending on the reflection law. The angle of reflection is equal to the angle of incident. To make sure that you have understand this lesson, try with the question 5 on page 106 and send me your answer to the email. And thank you for listening.